Hi guys, so this extension video is going to continue from what we did last week, where we're kind of looking at some of the trig that you guys are going to see when you get to pre-cal, just kind of combining some things that you did back in geometry and kind of looking ahead at how you're going to use those when you get to pre-cal. So what we're going to look at first is just reviewing your special right triangle ratios. So this is something pretty important that you guys learned in geometry. You've probably seen it come up a bit with your SAT, ACT kind of prep questions, but there were two types of special right triangles. You had a 30, 60, 90, and you had a 45, 45, 90. Those triangles had special ratios. For your 30, 60, 90, across from the 30 side was x, across from 60 was x times the square root of 3, and across from 90 was 2x. On the 45, 45, 90, it was across from both 45s was x, and across from 90 was x root 2. Now, what's nice about that is you can have any value take the place of x, and it can be a 30, 60, 90 triangle. So what we're going to do is we're going to use that concept to determine the sine, cosine, and tangent of certain degrees. So we're going to start with the sine of 30 degrees. So what I'm going to do is I'm going to go ahead and draw a triangle with a 30-degree angle. And again, we can pick any values we want for x. So I'm going to pick the easiest x value possible, and I'm going to let x be 1. Well, if x is 1, then across from 60 would be 1 times root 3, and across from 90 would be 2 times 1. So this is a 30, 60, 90 triangle. Now, even if I change those values, if I make this 2, root 3, and 4, it's still going to have the same ratio. So when I do sine, cosine, and tangent, my opposite over hypotenuse or adjacent over hypotenuse, they're still going to have the same ratio. So I'm going to pick the easiest values to determine what this is. So if I want the sine of 30 degrees, based off this picture, all I want is the opposite over hypotenuse, which is 1/2. Cosine of 30 degrees, I want the adjacent over hypotenuse, which in this case would be root 3 over 2. Tangent of 30 degrees, I would want the opposite over adjacent, which would be 1 over root 3. If you rationalize, then it would be root 3 over 3. Same idea for a 45, 45, 90 triangle. I'm going to pick the easiest possible values. Now, again, you can pick any values you want. The ratio is going to be the same. But if I use 1 and 1 and root 2, it fits that ratio, and I don't have to worry about reducing. So if this is my triangle, here's 45. Opposite of 45, opposite over adjacent would be 1 over root 2. Or you can rationalize it to root 2 over 2. Cosine adjacent over hypotenuse, root 2 over 2. Tangent of 45, your opposite over adjacent is 1 over 1, which is just 1. All right, looking at that 60-degree angle. Again, it's still that same 30, 60, 90 ratio. We're just going to use the 60 as our reference point for our opposites and our adjacents. So across from 30 is 1, root 3, and 2. So sine of 60 degrees is opposite over hypotenuse. So opposite of 60 is root 3, hypotenuse is 2. Adjacent to 60 is 1, hypotenuse is 2. Tangent is opposite over adjacent, which is root 3. Now, one thing you may notice, those sine and cosines for 60 and 30 are actually the same if you flip them. There's a property you guys will learn when you get to pre-cal about cofunction angles, those ones basically that add up to 90, and how you can find some values that way. All right, so what we're going to do now is we're going to use that same concept to find some common angles trig values. So what's going to be really helpful for you guys to know are these 3 radian conversions. And these 3 will come up a lot whenever you get to pre-cal. So remember, we talked about this in the last video. If you want to convert from radians to degrees, you can multiply by 180 over pi. But these 3, like I said, they come up so often, it's really helpful just to know them. Pi over 6 is 30 degrees. Pi over 4 is 45 degrees. And pi over 3 is 60 degrees. The reason those 3 are so helpful is because when we talk about reference angles, what's really convenient about all 3 of these whenever you find your reference angle is that it doesn't matter how many pi's over 6 you have, the reference angle is 1 pi over 6 or 30. Same thing with pi over 4 and same thing with pi over 3. So if you have 17 pi over 3, the reference angle is going to be pi over 3. If you have 27 pi over 4, the reference angle is going to be pi over 4. Now, you still need to determine which quadrant it is because that affects what's positive and what's negative, but it's not going to be affected by what the actual value is. Same thing with pi over 6. As long as it's reduced, Again, with those pi over 3s, as long as the pi over 3s and pi over 6s are reduced, that's going to be your reference angle. So the reference angle of 11 pi over 6 is pi over 6. So we can use that to help us draw these triangles in order to be able to evaluate what these things are. So we'll start with a degree value because those are a little bit easier. So I want to find the sine of 210 degrees. So I'm going to find the opposite over adjacent on this triangle. But instead of using 210 degrees, because I can't make a triangle with that, I'm going to use the reference angle. 210 tells us which quadrant to draw this in, and that tells us where our positive and negatives are going to be. So I want to draw 210 degrees. Well, we know that that's going to be in quadrant 3 because we know it's past 180 and we know it's not quite at 270. Then this is why reference angles are helpful. I'm always going to draw these triangles in relation to the x-axis because that's what our reference angle is. So in relation to that, our x-axis, if this is 180 and this is 210, that reference angle in between is 30. So now I'm going to fill in those values for a 30, 60, 90 triangle. Again, you can pick any values you want. I'm going to pick the simplest ones. Across from 30 is 1, across from 60 is root 3, and across from 90 is 2. Sorry about that. Wow. Now, the reason the quadrant matters is because even though the absolute value is going to be the same as a 30 degree, because of the angle that it's in, or the quadrant that it's in, your positives and negatives could be different depending on the quadrant. So what I need you to consider is, let's say we have something in this third quadrant. So if we consider where this is in that quadrant, think about any point that you would plot in this quadrant. Well, if you're going in your x's, you're going in the negative direction. Vertically, you're also going in the negative direction. So that's actually going to be a negative root 3 and a negative 1. So once our triangle is drawn, now what we can do is we can just evaluate the sine of 210. So we want the opposite over hypotenuse. So from that 30 degree angle, my opposite over hypotenuse is negative 1/2. So the sine of 210 degrees is a negative 1/2. All right, now let's try a radian value. So what we need to know for radian values are two things. One, which quadrant is this going to go in? That tells us our plus and minus. And two, what's the corresponding reference angle? All right, so let's look at 5 pi over 6. 5 pi over 6 is going to be in quadrant 2 because it's not quite 6 pi over 6, but it's closer to 6 pi over 6 than it is to 0. Since it's a pi over 6 value, all of your pi over 6s are going to have a reference angle of 30. So now we're just going to fill in our triangle. Across from 30 is 1, across from 60 is root 3, across from 90 is 2. And then looking at our positives and negatives, the 1 is going to be positive because if I'm going vertically in that direction, that's positive. That root 3, though, is going to be negative because, again, you're going in the negative x direction. The hypotenuse on these, I didn't mention this in the last one, your hypotenuse is always going to be positive. Because, again, think about Pythagorean theorem. If you square x and you square y and you add them together, you're going to get a positive value because when you square those negatives, you end up with a positive. Once your triangle is labeled, cosine is adjacent over hypotenuse, which is negative root 3 over 2. All right, then we go to the next one. Tangent 3 pi over 4 again. First thing we need to determine is correct quadrant. 3 pi over 4 is going to fall in quadrant 2 because 3 pi over 4, it's not past 4 pi over 4, but it's closer to 4 pi over 4 than it is to 0. Reference angle for every pi over 4 is 45 degrees. So fill in our values, 1, 1, root 2. Positives and negatives, the 1 at the bottom should be negative x direction. Once your picture's drawn, find your ratio. This one's tangent. Tangent is opposite over adjacent, so 1 over negative 1 is negative 1. So the tangent of 3 pi over 4 is negative 1. Now, there was another way to get these values, and this is something you guys are probably going to use a lot in pre-cal, and you're going to see a lot in pre-cal. But I wanted you guys to see that so you kind of know where these values are coming from. What we're going to do is we're going to look at something called the unit circle. And the unit circle has a lot of these trig values on it, and we're going to talk about where they come from. So we're going to start with the same triangles that we've been using. The only difference is we're going to use the same ratio, but instead of picking 1 for our x, we're going to let our hypotenuse be 1. So if I start with this triangle right here, let's say this is 30, this is 60, and that's 90. Okay, that ratio is still x root 3, and 2x. But instead of plugging in 1 for x, I want to make the hypotenuse 1. Well, if my hypotenuse is 1, then 2x is equal to 1, so my x is 1/2. So across from 30 is 1/2, and across from 60 then is 1/2 root 3, or root 3 over 2. Now those values may look familiar because we just saw them on our first example, but you'll kind of see that here in a second. All right, looking at this next triangle, 60 and 30. We're still going to let the hypotenuse be 1. All right, it's still going to have those same values. Across from 30 is 1/2. Across from 60 is root 3 over 2. Now let's look at a 45, 45, 90. All right, so my hypotenuse is going to be 1. So that means that 2x is equal to 1. So x is equal to 1/2. And I don't know why I use 2x and not root 2x. Wow. So x root 2 is your hypotenuse of 45, 45, 90. So x root 2 is equal to 1, which means that x is equal to 1 over root 2. If you want, you can rationalize that, and it'll make that root 2 over 2. Now, the reason that we're drawing these triangles this way is so you guys can see how these fall on what's called the unit circle. So the unit circle is a circle that has a radius of 1 unit. Okay, so let's go ahead and look at that triangle or that circle. All right, there's a lot of information here, so I'm going to black all this out for now because we don't need this yet. Okay, so we're going to look at, this is the unit circle. Now, the values that are on there are the really important ones that you're going to see most often. They're also the ones that correspond to the triangles that we just drew. So the first triangle we just drew, I used to have a software that would show this a lot prettier, but I'm going to go ahead and put this triangle right here. So this purple triangle is the second triangle that we just found the values for. Okay, this was 60, this was 30, this was 1, which is the radius of the circle. Well, the radius was 1, the value that we found that was on the bottom was 1/2, and the value that we found over here was root 3 over 2. Well, if you look at that point that's on the circle. What we're going to do is we're going to write the coordinates of that point, the x and the y. Well, I've gone over a distance of 1/2, and I've gone up a distance of root 3 over 2. So those are the coordinates of that point. All right, let's look at the pi over 4. All right, we use that 45, 45, 90 triangle. So when we did this one, again, the hypotenuse was 1 because our radius of this circle is 1. When we evaluated this and we found those 2 points, this was root 2 over 2, and this was root 2 over 2. So the side to side, the x distance of that coordinate right there, that point has an x coordinate of root 2 over 2 and a y coordinate of root 2 over 2. All right, the pi over 6, now we actually did that one going the other direction because I want you guys to see that over here. So this was the first one that was on your notes. So this was 30, hypotenuse was 1, this was 1/2, and this was root 3 over 2. So the coordinates of this point right here, I've gone in the negative direction, root 3 over 2, and I've gone up 1/2. So it's still the same values, so I'm going to go ahead and put that same triangle in here. All right, across from the 30 is still the 1/2, and at the bottom it's still root 3 over 2, and the hypotenuse is still 1. But again, what's different here is those positives and negatives. So what that means, all these triangles that I'm going to draw that have that 30-degree reference angle, let me go ahead and put all of them here in green, they're all going to have the same values. They're all going to be over a distance of root 3 over 2, and then a 1/2 as your up or down. We just need to consider the positives and negatives. Well, in the fourth quadrant, if I were to plot this point, I've gone a positive x and a negative y. So root 3 over 2 is positive, 1/2 is negative. This point over here in quadrant 3, both of those would be negative. All right, now let's go ahead and fill in all of the ones that had a 60-degree reference angle. So these are going to be all of the ones that have pi over 3 radian values. So we've got one here, we've got that one there, and we've got this one here. So it's still going to have the same coordinates. It's still going to be 1/2 root 3 over 2. But on this one, in the second quadrant, the 1/2 is negative because your side-to-side distance is negative. Down here, they're both going to be negative. And in quadrant 4, your x is positive, your y is negative. Then the last one, all those pi over 4s. Okay, again, root 2 over 2 are going to be the same coordinates. Okay, it's still going to be root 2 over 2 for both. But we need to consider positives and negatives. The x coordinate's negative in quadrant 2. They're both negative in quadrant 3. And the y is negative in quadrant 4. So the reason the unit circle is helpful is because not only is it a little bit easier for some of you guys to learn and just kind of memorize, because these are the values you're going to see so often, it's also helpful because of values like pi over 2 or pi or 3 pi over 2. I can't draw a triangle to determine those values, but understanding the unit circle helps me determine the sine, cosine, and tangent for those points. So the coordinates of those points are already listed, 0, 1, 1, 0, 0, -1, and -1, 0, because, again, the radius is a distance of 1. The positive, negative just depends in which direction you're going on that coordinate plane. So what we're going to do is figure out how to relate these coordinates to your trig values. Well, if you look back at the actual triangle, let me go ahead and draw this one. All right, my hypotenuse was 1. And then over here, my opposite of my 60 was root 3 over 2. The opposite is the y-coordinate. That's your sine. So the y-coordinate is the sine. So the sine of an angle on your unit circle is the y-coordinate. All right, when we drew that triangle here with that reference angle, cosine for that 60, all right, this was 1. This was 1/2. Adjacent over hypotenuse was 1/2. That's your cosine. That is the x-coordinate of those points. Tangent, okay, is what we get if we do opposite over adjacent. Well, let's consider opposite over adjacent on this picture. Opposite is the y, adjacent is the x. Opposite over adjacent is y over x. It also kind of looks like the slope of that line if you consider that as well. So tangent kind of works out like your slope. Look at this point right here. Okay, tangent there is 1. The slope of that line is 1. Okay, so now what we're going to do is use that idea to be able to find some other values. So let me go ahead and erase the stuff that I blocked off. One thing, there is a little trick to help you remember your positive and negative signs. So you can always think, hey, if I plot a point up here, what's positive, what's negative, what's x, what's y. If I plot a point over here, the x and the y are negative. But to help you relate that faster to your sine and cosine values, there's a little acronym. It's called All Smarties Take Calculus. So it goes in quadrant order. All stands for all. All of your trig functions are positive in the first quadrant. S stands for sine. In the second quadrant, sine is the only, sine and its reciprocal, cosecant, are the only functions that are positive. In the third quadrant, tangent and its reciprocal are the only trig functions that are positive. And in the fourth quadrant, cosine and its reciprocal are the only trig functions that are positive. So that's just a little thing you can help to use to help you to remember your positives and your negatives. But again, you don't have to learn it that way. You can just think, if I plot a point here, what's positive and negative between your x's and your y's? Okay, so now let's go ahead and do this. So instead of drawing triangles, we're going to go ahead and use the unit circle to evaluate these. It's a lot faster. You just got to know it, and you really have to know that unit circle. Now let's look at the cosine of pi over 2. So cosine is going to be an x-coordinate. So on the unit circle at pi over 2, I just need the x-coordinate. Well, the x-coordinate at that point is 0. So the cosine of pi over 2 is 0. All right, 11 pi over 6. So 11 pi over 6, it wants the sine, which is the y-coordinate. So at 11 pi over 6, my y-coordinate is negative 1/2. All right, tangent of 2 pi over 3. So I'll go to 2 pi over 3. Tangent is y divided by x. So this is going to be root 3 over 2 divided by a negative 1/2. Or root 3 over 2 times the reciprocal, which becomes a negative root 3. So the tangent of 2 pi over 3 is negative root 3. Then the last one. So the last one is the reason why it's very important for you to be able to determine which quadrant a radian value falls in. Negative 11 pi over 3 is not in this unit circle. Now we know 11 pi over 3 is going to have the same reference angle as all of your pi over 3's. So we know that it's going to be the x-coordinate of your pi over 3's. So it's either 1/2 or negative 1/2. To make sure we get it correct, though, we need to make sure that we have this in the correct quadrant. So negative 11 pi over 3, it's not on the circle, so we need a coterminal angle. So I would take negative 11 pi over 3, and I would add 2 pi, which is 6 pi over 3. Now, if you can look at backwards and determine, hey, I'm going to go back negative 5 pi over 3, you can see where this falls. If that's still kind of hard, though, you can add that 2 pi again, and you end up just with pi over 3. And that tells you that this is going to fall in quadrant 1. So negative 11 pi over 3 and pi over 3 are coterminal. They're going to have the same cosine value. Cosine is the x-coordinate, which is 1/2. All right, so that's it for this little extension. It's kind of just a preview of the stuff to come for you guys in pre-cal. This unit circle, you're going to spend a lot of time with this. You'll learn a lot more things about it. This is just kind of introduction, so you guys kind of know where these values are coming from. But like I said, you'll spend a lot more time with this when you get to pre-cal.